So yeah, good morning everybody, and welcome to this new webinar and first webinar of 3E about solar irradiation data. To present it today, I'm glad to do it with my colleague Grégory. Hi, Greg.
Hi, David. Hi, everybody. Thank you to join. It's a pleasure.
Greg, thanks. Greg is the head of operation in France and North Africa for 3E for the expert services activity. He's really our expert, right?
Yeah, exactly. So I'm working at 3E since 16 years now, and I was in charge of resource assessment, technical advisory for the group, and now I take the lead on all the operations in France and North Africa since a few months when 3E reorganized a bit the organizations.
Thanks, Greg. For my part, I'm in charge of the business acceleration, which means the business development for all the new digital application that 3E is developing as part of our general SaaS solution called Synaptic. Before we start, just a few practical information about the webinar, everybody. You are all muted, but there is still a chat box in which you can ask your question, share your remarks and everything. The presentation should last about 15 minutes, and we should have about 10 minutes to answer your question. We'll do our best to answer them all. Don't hesitate to drop any of your feedback. And also by the end of the webinar, when you quit, you should also see a small survey, so please would be super great if you could answer it. All right, so that webinar, as mentioned earlier, is the first one of a series of webinars we want to do about solar irradiation data, project development, optimization of your energy yields, and also optimization then of your project value. The topic is today how to optimize indeed your project value based on accurate solar data, how to with a simple method, how to optimize your project value by using this accurate solar data. So before we jump right into that topic, just a few words about 3E for those who don't know us. 3E is a technology expert company. 3E was created in 1999, so about 25 years ago already. We started by the expert services or the technical advisory side of things, and in 25 years we've developed more than 5,000 projects all over the world, which sums up to a capacity of 90 gigawatts. Solar, wind, any type of technology related to the solar and wind energy. This has made us one of the most trusted technical advisors around the world by the financial institutions. And 10 years ago, based on that very strong domain expertise in solar energy and wind energy, we decided to develop our own SaaS, starting by the performance optimization of the asset when it's under operation with a very powerful digital twin. And today we are glad to say that we have 12 gigawatts connected to our platform with more than 10,000 plants. And it means also that 10,000 plants are using every day on real-time or almost real-time our solar irradiation data model. And this is why we took that model and made it available for project development. And hence, it's another reason to do this webinar. All right, let's start and jump into the topic. Greg?
Yeah, so based on our experience, we have let's say 20 years of experience, so we saw many projects, and we can see where the input is important, and especially the accuracy of irradiance data when you look at the PV system. And we can see that we have 3 stages that can be useful to have accurate data. The first one is, of course, when you're developing project and you go through the finance stage, you need to have accurate data that can improve the quality of your project, also accelerate your development, and to obtain a nice, let's say, loan and financial conditions for your project. So accurate data in that stage is, of course, very important. The second one, which is when you can use irradiance data, is when you have operations that are under assets under operations, and you need to refinance the project. And in that case, you base your analysis on real production data, often about 2-3 years of productions, and you need to extrapolate this operation data over a long-term period. And in that case, you need to have accurate data in order to evaluate and refinance your project at the proper level. Then the third situation where your accurate data can be used is, of course, when you make an M&A, meaning when you have to finance or refinance, acquire or sell a portfolio of projects. It's true that if you have accurate data, that means you can obtain better loan conditions and also to generate better leverage on your of your portfolio. And in that case, you can reduce partly the equity or reduce your equities. That means equity can be available for other projects, and in that case, you can accelerate and your development by increasing your portfolio again. So to have accurate data in that stage, 3 stage, is for us very important. And based on our experience, we saw that we have to rely on accurate data in such a phase to improve your assets analysis.
Thanks, Greg. So yeah, let's talk now about, or let's set up together a business case. Let's say we have 100 megawatt plants we want to build, so we want to develop it first. And let's say we are in Spain, and we have downloaded a TMY file, and the GHI value is 1,800 kilowatt hour per square meter. So of course, most of you would know and would use, for example, PVCs, but of course another software would work. And you do the design of your system is a fixed PV system, and the PR value is set up at 80%. What happens on the output? Very simply, the specific production P50 goes to 1,647 kilowatt hour per kilowatt peak. And so per year, you would inject into the grid about 165 gigawatt hours. So that's the setup of your business case. You have your specific P50, and now you are going to go into all the exceedance probability calculation and the uncertainty evaluation around this production value, because you want to estimate and optimize these production values.
Thank you, David, for presenting this setup of project. So as David said, it's true that we now obtain a P50 value. We take some assumptions and hypotheses to obtain it, and you need to evaluate the risk, or let's say the reliability of your project. And for that, you need to estimate the uncertainty on your estimation over the P50. So at 3E, okay, we have several kinds of uncertainty sources. And here in this example, we divided in 4 categories. The first one is, of course, the irradiance measurement uncertainty. So it's typically what is the accuracy of your irradiance data that has been used to identify the yield of your project, so the horizontal irradiance. Here, for the example, we take 5%, which is a value, a generic value, a standard value for normal irradiance data sets. The second categories of uncertainties that is also used on this project is the climate variability. Climate variability over 10 years. Why 10 years is because often you look at the revenue, or let's say the financing of your project over 10 years. So the climate variability is the way you take a period of 10 years, what is the variations of a period of 10 years compared to another 10 years periods. Actually, typically, these values is estimated by 1.3%. The third category of uncertainty that is in your model is in-plan conversions. So for irradiance, you have it on a horizontal, value, GHI, sorry. And you have to convert it on a plan, meaning you have to consider the tilt and the orientation of your assets, and you have some assumptions and maybe inaccuracy of on your model. A typical value, a standard value for this uncertainty is 2%, which is a normal value. Now, the fourth categories on a long-term age assessment is we group a certain number of uncertainty for this example, named PV modeling. Under PV modeling, you have uncertainty on module, on optical chain, on degradation factor, on the EIM. All this kind of uncertainty is grouped, and we simplify the model, and we take an overall uncertainty of 3%. Now, if you have now 4 categories of uncertainty, and because each uncertainty are independent to each other, you can group it by using a root mean square formula, and to obtain a global uncertainty on your project. This uncertainty can be the distribution of your production is following a Gaussian model, which is like that, and the uncertainty helps you to identify the probability of exceedance of a certain value. So here it's a P90, meaning you have 90. If you take 10 years of production, the next 10 years, you will have 90% of your time production at least equal to this value. So for the example here, with an uncertainty of 5% on the irradiance, 1.3% on climate variability, 2% on in-plan conversion, and 3% on PV modeling, you have an overall uncertainty equal to 6.3% over 10 years. This 6.3% is then used to calculate the P90 value.
So let's look at that P90 value. As Greg mentioned, and very important to remember, this total uncertainty of 6.3% can be used for the calculation of any exceedance probability. So now the P90 value for this project is 1,514 kilowatt-hour per kilowatt peak. And if you may remember, it's also written on the slide, the P50, which is 1,650-ish kilowatt-hour per kilowatt peak. It means we have a gap between the P50 and the P90 value, about 8%. This is something that you may want to remember, this 5%, this 8% value, because it's the distance you have between these two values. And of course, when you try to optimize your project, you want to reduce this distance. You want to have your exceedance probability as close as your P50. If you convert that into revenue for our existing and current business case of 100 megawatts and 80 euro per megawatt hour, what does it mean in terms of revenue? It's a quick calculation, but your P50 is about 13 million euro per year, and your P90 5%, called 5% because it's done with the 5% irradiation data uncertainty, is at 12.11 million euro per year. So that's your basic setup with your basic exceedance probability. Now what we are going to do is simply to reduce the uncertainty on solar irradiation data because we managed to get more accurate one, and Greg will show you the impact on the uncertainty value.
Yeah, thank you, David. So if you now take back the tables that you have presented to you in the past, so now the only variables that be improved is the accuracy of the reagents, meaning you use solar data, which is more accurate. In that case, you are more confident with it, and you can decrease the uncertainty on this variable. So now, if you look at, you pass to 5% to 3%, meaning the error, you identify a decrease of the error about 2% on your data sets. If you consider the same formula, you pass, if you consider the standard value of 5%, you add 6.3%. Now, with this new 3% accurate value for the more accurate data, you decrease the overall uncertainty to 4.9%, meaning you decrease the overall uncertainty to 1.4%. And this will have a large impact on your P90 value, because and also on the P80, P75, each probability of excellence will be impacted by a reduction of the overall uncertainty. And by doing this, you can have more leverage, you can be more interested with your project, and it will be easy to develop and build it.
Thanks, Greg. So let's see indeed that new calculation of your probability of P90 with our 3% new uncertainty, because we got more accurate solar data here. Let's look at the same plot than earlier on. The blue curve was the old curve, and the orange one is the new curve with our 3% uncertainty on the solar irradiation data. You can already see that it is more concentrated. It's less wide, it's more narrow, because we have reduced the standard deviation. So the older P90 was close to 1,500. Here, and now we can see that we have a better P90 value, which has the exact value of 1,544 kilowatt-hour per kilowatt peak. What does it mean? What does it mean for you? Because now we are only talking about calculation and mathematics, but it still means that you reduce the gap between your P50 and your P90 by 2%, because now it went from 8% to 6%. Or in other words, you have increased your P90 automatically, and that's very important. Automatically, you increase it by 2%. If you look at more numbers, more money side, your P90 has then increased in terms of value, and it went from 12.1 million per year, pretty much to 12.4 million per year. So mathematically, just by choosing more accurate solar irradiation data for this specific project, you have increased your P90 value by 242 euro per year. As simple as that, just by using more accurate solar irradiation data. So it's more certainty about the revenue that you can make. And we know that the P90 value is very important also when you build your business plan and you go to see any lenders and any potential investors. Let's now take that example of 2%. We went from 5% uncertainty to 2% uncertainty that you can see on the orange bar. So we decreased basically the uncertainty by 2%, and we can see that the P90 has also increased by 2%. So it's a simple method, mathematically speaking, that we are sharing here, and this method shows you that it is almost a linear model. The relationship between the P90 variation and the solar data uncertainty value is almost a one-to-one rule. because it's almost a linear model. It's something that you may remember as a takeout from this webinar is indeed what I just named earlier on, the one-to-one rule. By increasing by 1% the accuracy on your solar data, you will also have almost an increase of 1% of your P90 value for the same P50. Of course, the other impact here about using more accurate solar data is that you have a more accurate P50 value because your confidence interval gets smaller. But here, the most important and that we would like you to remember about that webinar is this one-to-one rule. 1% more accurate data, 1% P90 increase, P90 10 years, of course. Of course, also, if you convert it into revenue for our project of 100 megawatts, but it will give you also an order of magnitude for any other type of project you may want to develop. With an electricity price of 80 euro per megawatt hour. So decreasing the uncertainty by 2% of your solar irradiation data will also lead you to an increase, of course, of your P90 and so an increase of your revenue. In that specific case and specific with this specific value, it means that 1% increase relates to 120 kilo euro increase per year, mathematically. So in your business plan, one more time, you increase your revenue while your CapEx and OpEx will remain the same. So if you increase your revenue with the same cost, you are also increasing your return on investment on this project or your TRI. So that's really important. Now we have demonstrated the impact of this accurate or the impact of choosing accurate data. You may ask yourself or may want to ask us, how do you choose more accurate data? How do I do in my project development phase when I have to discuss also with a technical advisor or myself to estimate the uncertainty values? Where can I find accurate data, or how do I select a bankable, accurate, and also a competitive database or data provider? So as a technical advisor, 3E, we do that on a daily basis for more than 20 years. So we have 6 recommendations to share with you on how to select a good data provider which tick these 3 boxes: bankable, accurate, and competitive. If we look at more the data type and model performances, the first recommendation that we can do is we would like to favor more satellite-based data over station-based data. The reason is very simple. It's a matter of numbers. Satellites are taking pictures of the Earth every 10 or 15 minutes continuously, which means that every 15 minutes we receive on the Earth 15 millions of pictures, which is a huge number. Now, what is available, and even though it may grow in terms of network of station, is about 6,000 stations around the world. So you see the difference of numbers. You have more chance to capture what's going on the local climate. If you don't have yourself your meteo station on site, you have more chance to capture what's happening with the satellites. And I will go even further with that. There are new satellites being launched recently, or which are going to be launched, and the resolution is going to increase, and so the accuracy is also going to increase. So yeah, we favor satellite-based data. The second thing you may want to look in the technical terms is choose or look for continuous model improvement. So choose data providers who are providing databases which are constantly updated. It's very important because especially within this context of global warming, we see some non-homogeneous temperatures around the world, and so the TMY, which is the typical meteorological year, so a typical year value will change. And if you don't take a database that continuously capture the latest GHI value, temperature value evolution, you will not have the most accurate TMY. Number 3, in terms of recommendation, is more related to the validation. As you all know, there are many different types of climates, many different types of topography, etc., etc. And we strongly recommend to always choose a database which has validated over than 150 sites. The reason is you want to cover these different various type of climates and topography. So at least choose someone or choose a database which has done this, I would say, extensive number of sites validation. Another thing you may want to have is also this data provider will be even more trustable to us as a technical advisor, and also then to the lenders if there is also an independent third-party validation available transparently and also recent. And generally speaking, if I speak about the performance of the model and the values that we can share, we have seen over the years that when you choose a data provider which has a mean bias error below than 0.5% and the standard deviation below than 3% on average over these 150 sites, you are going to select a trustable and accurate database. We know that some sites will have higher standard deviation and higher mean bias error because they are in specific climates, but it's just to give you an order of magnitude. If you have a standard deviation below than lower than 3% on this 150 site as an average, it means that you have a very good and consistent database as a provider. Last recommendations, the last two. We believe that solar data have to be accessible to everybody. In terms of usage, we also truly believe that it's experience that brings you also confidence into a specific database or more than one actually. So please try yourself the data for free from many different databases. Compare them against peer anometers value that you have. Clean data, quality check data, but you can compare them and do yourself your benchmarking and build yourself the experience and the confidence into a specific database. This is also the last recommendation. It's very related to it, but as data should be accessible to everybody, good data should be accessible to everybody. We also believe that if you have simple access to the data via a specific plan, specific subscription in kind of unlimited manner, it will really help you to use it in many different type of climate, many different type of project for you, and you will end up being also more confident into this this type of solar data. So it's really important that you are not limited with a certain number of downloads. Because you really have to use it and to know how it performs in different type of projects. Right, that's the last recommendation. In a nutshell, test it, use it as much as possible. Use different data providers to really make your choice. I believe we are past over the time. I see that there are already some questions coming up. Please shoot your question. Let me check in the list. What do we have as questions?
Ready answer to one. Ready.
So first question is the method you use approved by the technical advisors and banks? Greg, I'll let you answer that question.
I suppose it's a question related to the estimation of overall uncertainty. Yes, this method is the one that is commonly used in all technical advisory audit, and is also well understandable by the lenders. So this method is the one that has to be used.
Thanks, Greg. I hope it answers the question. Feel free to drop your comments. Another question we have received is what GHI uncertainty should we expect with highest quality of 12 monthly on-site measurements? Basically, Greg, what happens if we have 12 months of pyranometer data and you do your correlation with satellite-based data? How low can we go in terms of uncertainty?
Okay, so it's difficult to give a real figure because it's really depending on the quality of the recorded data. But we have in the past many examples, and we can reduce by 1% the uncertainty on the irradiance if you have on-site measurements, more or less. Yeah, this is what can be expected. If you have on-site measurement, if you consider the 5%, you can decrease, or let's say 3.5%, you will have between 2 to 2.5% uncertainty on the irradiance data by using on-site measurement data.
So, Greg, just to complement,
you gain 1%, 1 to 1.5% of uncertainty if you have on-site measurement data, because you still have to correlate it with irradiance data to long-term extrapolate it.
And you also have additional uncertainty coming from the sensor itself, right?
Exactly. That's why you can't really drop down the uncertainty if you have on-site measurement data. It's not. You still have some uncertainty on such a device, and also the MCP method, which is the method used to long-term extrapolate the measured data.
And so would you say also that if you have a 5% uncertainty, you will go down to 3 to 3.5% if you do a 12 months on-site measurement campaign?
Yep, exactly.
Yeah, it's an order of magnitude, right?
Exactly.
Okay. I hope it answers to the people who have asked these questions. I see another one. How do you calculate the climate variability for a 10 years time series?
Okay. In fact, what we are doing, we look at the long-term data set that we are using. So we can have 20, 25 years of data, and we selected we convert each. We have the data on an hourly basis. Then we group it in monthly and then yearly, and we look at one period of 10 years, and we make a rolling period over the overall long-term data set. So that means for 25 years of long-term data sets, you will have 15, more or less 15 rolling period of 10 years. And then we look at what is the variability of this irradiance over this 25 period if you take rolling period of 10 years. And 1.3% is a result of this evolution. Of course, if you consider still considering 25 years of long-term periods, and you look at the on a yearly basis, your climate variability on a yearly basis with 1 year data will be more or less 4%, because you can see that if you take 1 year in 2002 and 1 year in 2010, for example, if you have the curve, the standard deviation will be more or less 4.5%. More you are using a rolling period which is longer, 10, 20, 15 years, in that case, your climate variability will decrease. But the biggest drop is between the climate variability 1 year to 10 years. Then 10 to 15 or 20 years, the gain is really less, because you don't have a lot of difference between a period of 10 to 15 or 20 years. Okay. It's different comparing with the wind, to make the parallel.
I see other question coming in. Can you share a bit more about our MCP methodology used in 3E, Greg?
I'm not the one which is developing the tool, but to be clear, in fact, you take your on-site measurement, you make correlations between the long-term data sets and your measured, and then you extrapolate using a Pearson coefficients. So timestamp to timestamp, and then you have a long-term time series by using a correlation factor. But if you would like to have the full methodology, we can give you a paper related to this, because it's we have R&D department that developing the methods and can have more example and more detail on it behind with the formula. It's a bit long to explain in 2 minutes.
Okay. No problem. I think we take one more question. I see a lot of questions coming in, but we have to wrap up. So what we propose is, after this last question is answered, we will answer to your question separately. We will send it by email, the answers, and we can discuss about it. Let me just choose one randomly. How to check accuracy of data, whether to go with Solar GIS or Metonome or Tree or Solarcast or Solar Anywhere. That's a very good question. Actually, might take some time to answer it. I can answer partially in a nutshell here. So how do you do? The first thing that we recommend is, first, you see the 6 recommendations we provided. Make sure that these 3, 4, 5 providers are ticking these boxes. The second thing that you have to do is, when you know where is your site, check validated sites which are near your site. So let's say you are, for the business case that we took during the webinar, in Spain, check how many sites by each provider has been validated in Spain, Portugal, and nearby, and check what were the performances in terms of standard deviation, mean bias error, root mean square error, etc. So it will give you an idea about the performances of that provider. And once you have this, then we strongly recommend also that you download 1 or 2, minimum 2 data sets from 2 different providers, so 1 each. And then you compare also the GHI values, and you see if there is a big gap. If there is a big gap, means you need to dig deeper and you are in a specific climate with a fast changing mass of air, so clouds coming fast and disappearing fast. Otherwise, it means that you are fairly consistent with these 2 data sets. So that's in a nutshell how you can do it. And this is in a nutshell, one more time, how our technical advisors are choosing the uncertainty on the solar data. I see that there are a lot of other questions. And it's really nice. Really glad that you share this question. I will answer to the question by email, and we can get back in touch as soon as possible if you need more details. We are openly happy to share and be transparent about it. Right, so yeah, thank you everybody. The webinar is recorded. I see also this type of question is recorded. It will be sent to you by email. You can watch it again. You can try our data sets for free. You can simply request a free account in our web application. You can download the data for free on 3 different sites, and you can just play with them. If you need any type of services related to technical advisory, resource assessment, technical due diligence, etc., don't hesitate also to contact Greg. Drop any question you have. This webinar aimed to be informative and not commercial. So we are gladly sharing one more time any information we can to make solar energy developing faster in the world. And we hope to see you soon in the next webinar, which will be also related to the project development with another very interesting topic. Thank you, everybody. Have a great day ahead, and see you soon, hopefully. Bye-bye.
Thank you, everybody. Bye.